Chapter 3 is all about putting the electrons into the orbitals we talked about in Chapter 2. But before we get too much into it, I do want to sort of start talking about the periodic table. We've used it like this much, but we got to get some vocabulary about it and kind of move a little forward on it. So the history of the periodic table is basically comes from a variety of people. Mendeleev and Moseley get the most of the credit, but this recognition that there are certain periodic properties of the elements. So, and what they see is that there's something like an octave, that every 8 elements in increasing mass seem to have the same properties. And so they notice this sort of pattern. And Mendeleev was the one who said, hey, let's put it into a table where each row is 8 elements long. Now we've gotten much more. We have much better detection methods. We've found a lot more elements. But the idea of the structure of the table comes from that. Vertical columns are called groups. That's because everyone in that first position has the same periodic property. That period means like it's like a period, and then it goes back to the beginning again. So everything in the same group or column has the same chemical properties. They're going to behave similarly. There are 4 periodic groups that are going to have special names we're going to have to know. And then we call each row a period because it's sort of the thing that repeats. So the rows are called periods. The ones on the very bottom are special series that are part of it's not the entire period, it's a piece of the period. And we'll talk about those in a little bit. Also, we've already seen that it's ordered by atomic number. The atomic number are the whole number that are in the box with the element, and they increase from left to right, top to bottom, and that's the sort of structure of the table. How you read a table, you would read it in terms of atomic number. And then there's this thing that's not shown on every table, but it's a really important thing, and it's kind of a staircase over towards the right-hand side. We call that the staircase. And it's going to divide the periodic table into 2 types of elements, and that will become important soon. So if we look at a picture of this, we can see some of these things I was talking about. Again, this is called a periodic group. Every column is a periodic group. Every row is a period. So we'll talk about groups and periods, and we won't talk about rows and columns. We have this staircase, and then we have these whole numbers that are the atomic numbers. Sometimes they're above the chemical symbol, sometimes they're below the chemical symbol. It depends on the specific periodic table, but it's the whole number, whereas the other number that's in the box is not a whole number, has a decimal point and some details after it. That's the atomic mass. So there's some special groups and series you need to know. The very first group, note that the groups are actually numbered 1, 2, 3, 4, 5, 6, all the way up to 18. There's a couple of different numbering systems. Another way to name them involves numbers and letters. There's A groups and B groups. We're just going to use 1 through 18 because it's simpler. But we also need to know some special names. So group 1 is also referred to as the alkali metals, and group 2 is also referred to as the alkaline earth metals. Group 17 is also referred to as the halogens, and group 18 is also referred to as the noble gases. So we need to know those. I expect you, when I say noble gas, I expect you to know that's one of the elements in group 18. The series we need to know are the lanthanide series and the actinide series. It's a little bit easy to remember because if I back up the lactinide, note that this number 58 comes right after 57, and 57 is lanthanide, and 89 is actinide. So you can see the little star indicating that really I should slice this whole table vertically between group 3 and group 4 and then put those series in that. That's how it would be. But that would be a super long periodic table that wouldn't print very well. And we don't use those series very often because they're very unstable and don't last. They have very short lifetimes. So they kind of take that portion series out and put it below the table so it's there, but it's not affecting the width. Just a kind of convenient factor. We also have this staircase breaking up into 2 different types of elements. So at this point, I want you to know that metals are the elements that exist on the left side of the staircase. Non-metals are the elements that exist on the right side of the staircase. If it is touching, any of these ones that are touching, so boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine, they are metalloids. We call them metalloids, which means they sort of can have properties of both metals and non-metals. aluminum is straight up a metal, so you just have to memorize that one. Germanium could be classified as a metal or as a metalloid. So if I'm only breaking it up into metals or nonmetals, I'll call it a metal. But if I say metal, metalloid, or nonmetal, then you'd say it's a metalloid. However, one thing that breaks the rule is hydrogen. Hydrogen is a nonmetal, even though it appears to the left of the staircase. But no, it's really not. It's above where the staircase starts, so this one is a nonmetal. That's just something you have to memorize. This is going to become very important soon. So it's important to know which ones are the metals and the nonmetals, and that the staircase divides them. The properties that they have are related to them being a metal and a nonmetal, but that's not what makes them a metal or nonmetal. So a metal is not a metal because it is shiny and hard. A metal is shiny and harder because it's a metal. So its position on the periodic table is affecting this property. But we will see that metals tend to react with nonmetals. They tend to be solids, have a luster, have that malleability that we can bend them and they don't break. High melting point, high density, whereas the nonmetals tend to be non-conductive, react with nonmetals or metals. They could be solids, but they typically are gases as one liquid, dull in appearance, low density, low melting point, brittle. If you hit them with a hammer, they don't bend, they break. So their properties are related to the fact that they're a metal or a nonmetal. But from now on, we will define metal and nonmetal as being its position on the periodic table relative to the staircase. And it's more than just a list of elements. There are so many patterns in the periodic table. And if you understand the patterns, simply looking at the periodic table becomes it's a wealth of information. It has so much decoded in there, but only if I know the patterns. And it's going to take a while to get to know all these patterns. But right now, there is a pattern in the periodic table that relates to the quantum number of the atom and those orbitals. We've already talked about that. That pattern of the quantum numbers is embedded into the periodic table, and that's going to show up a lot in this chapter. So it's important that we kind of bring up those words and vocabulary and we understand the periodic table.